Ma'am, can I start? Am I audible?
Yes, Rachana, you can continue.
Okay, ma'am. So, good morning, everyone. My topic is prediction of cardiovascular disease using machine learning algorithms. And these are the contents which I'm going through. So, first is introduction, literature survey, procedure, proposed system, methodology, advantages and drawbacks, result analysis and conclusion, references. So, firstly, why machine learning? So, machine learning is the aspect of machine learning is only important, like because as models are exposed to new data and also they are able to adapt independently, and this is because they can learn from the previous computations, so that they can provide reliable, repeatable discussions and results. Like while many machine learning algorithms have been around for a very long time, so the ability to apply the complex calculations to big data over and over is become faster in the recent development. So ML has several potential applications in the field of clinical trials and research. Applying ML-based predictive analysis uh, to identify potential clinical trial candidates can help research to draw a wide variety of data points, such as previous doctor visits, etc. So, applied machine learning in healthcare has also helped to identify cancerous and tumors. So, how this is done is like the machine learning can be trained to look up at images, and it is also used to identify the abnormalities and point to areas that need attention, thus improving the accuracy. So, ML is also helping improve the streamline administrative processes in hospitals, like to map and treat the infectious diseases. So the major challenge what the healthcare industry is facing is like a superiority of facility, diagnosing the disease correctly and providing the effective treatment to patients. This define the quality of the service, or else poor diagnosis causes the bad consequences, which will be difficult to handle in future and also not accepted by the real world data. Uh, in general, like real world data may be noisy, incomplete, and also, as we all know, that is not the data is incomplete. So, data pre-processing is required to fill the omitted values in the database. And also, healthcare is an inevitable task to be done in the human life. Cardiovascular disease is the broad category of the diseases that are affecting the heart and blood vessels. And we also know that since healthcare industry it contains a lot of medical data, so machine learning algorithms are very much required to make decisions effectively in prediction of heart diseases. So what is my project? This project is proposed is like prediction model to predict whether the people have heart disease or not, and to provide an awareness on diagnosis on that. So whether the people requires diagnosis, it is then we can this predicts whether the people require diagnosis or not. So how this is calculated is that the performance of the diagnosis model is obtained by, like we know that it's the obtained using various methods like classification, accuracy, sensitivity, and analysis. So this is done by comparing the accuracies of applying rules to the individual results of support vector machine, gradient boosting, random forest, naive Bayes classifier, logistic regression on the dataset taken in a region to present an accurate model of predicting cardiovascular diseases. So next is literature survey. So the first paper is published in 2019 by Avinash Golanje and Pawan Kumar T. So the name of the paper is the heart attack prediction using effective machine learning techniques. So in this paper, the main focus is on like they have also used various data mining practices that are essential in the heart disease forecast with the assistance of dissimilar data mining tools. Like this, the proposed methodologies are data pre-processing. Like we can split the whole database into like train data and split test data, and the training data is 80% and the test data is 20%. And classic decision tree, k nearest neighbors, k means clustering, and add list. So in this paper, we have used the various machine learning algorithms that is used for classification purposes. Classification of heart disease, and also we have seen the different techniques that can be used for classification and accuracies obtained by them. So this accurateness of the structure can be further upgraded by creating various combinations of data mining techniques. So the next paper, second paper, is published in 2018. So this paper is prediction of heart disease using machine learning algorithms. So in this paper, the algorithms such as naive-bayes, decision tree, and also the combination of algorithms is used for the prediction of heart disease, like based on the attributes. A Naive-Bayes algorithm is analyzed on dataset based on the risk factors. So the results shows that like when the dataset is small, Naive-Bayes algorithm gives the accurate results, and when the dataset is large, decision trees gives the accurate results. So what are the methodologies that are used in this paper are like data preprocessing, ID3 algorithm, Naive-Bayes classification, and k-means. So by this, what we can say is that Naive-Bayes results and decision tree results may change. So we need not have comparison of both algorithms to get accurate results. But if we use only single algorithm, it cannot pre-process and we cannot get into good accuracy. So this paper suggests to have the combination of algorithms like k-means and naive-bayes to get accuracy. And third paper is published in 2018 by Geeta. So to process vast amount of data, certain techniques are used. In this paper, data mining is one such method that is often used. This system predicts the arising possibilities, like what will happen in case of heart disease. The outcome of this system provides chances of heart disease in terms of. And also in this paper, the data sets are processed in the Python programming, like using two main machine learning algorithms, namely decision tree and naive Bayes algorithm. And also the algorithm uh, with the highest accuracy is chosen for the prediction of heart disease. During the small data sets, in some cases, the most of the times decision tree direct us to the solution which is not accurate, and naive-bayes direct us to the solution which is more accurate. So finally, we use a solution which uses more accurate, and the data must be more clean and well maintained. So naive-bayes gives us the accurate results. Even though ID3 can clean by itself, it still cannot give the accurate results every time. So we need to consider results of different algorithms to predict the results. Like if the variables are individual, we can generate the combination of algorithms like naive-bayes and k-means to get accuracy. And the paper 4 is this is published in the year 2018. The cardiovascular disease, the name of the paper is Prediction of Heart Disease Using Machine Learning Algorithms. Cardiovascular disease is one of the main factors that increase mortality. So in this paper, they've improved the cardiovascular disease prediction using better preprocessing phase. It helps to identify heart disease of a patient and guide to a doctor to diagnose better whether a person is having the cardiovascular diseases or not. In order to prove the results, there is also the comparison between different machine learning algorithms. Uh, Different machine learning algorithms, like using accuracy, precision, and overall performance. The algorithm used in this are like same algorithms like support vector machine, k nearest neighbor, and neighbors. So, to sum up, pre-processing is a crucial step in the machine learning as it helps to achieve better results. The purpose of this paper is to compare performances and to improve the efficiency. The results prove the score accuracy is 86% and was achieved by using SVM. So the SVM is having more accuracy in this paper. So the future is to find new approaches to enrich this domain. What are the heart disease risk factors and the symptoms of heart attack? So as we can see, the heart disease risk factors includes high cholesterol, blood pressure, and diabetics, smoking, too much alcohol, overweight, and symptoms of heart attack are symptoms of heart attack are like shortness of breath, pain in chest, fatigue, cold sweat and unsteadiness, irregular heartbeat, heartburn or abnormal pain. So, procedure is like healthcare databases have collected a significant amount of patients' records. Cardiovascular disease like is one of the deadliest diseases in the nature. The term cardiovascular disease deals with the situation like the heart and blood pumping and circulation of blood takes place in the body. Records were obtained from the Hungarian, Switzerland, and many database. These data sets segregate the patterns that are related to the disease. So the records classifies into two types. Like as we all know, training data and testing data. And next is analysis of data. Now, this phase includes the major performing data pre-processing such as data cleaning. As we all know, data cleaning and data integration, filling of missing values and removing redundant data. As the dataset contains missing values and redundant data, it leads to fault prediction. So what is data cleaning? Data that we want to process will not be clean and it may also contain noise or missing values so that we cannot generate the good results. So to obtain good and perfect results, we need to eliminate all this. And data transformation. This involves the changing a data format from one to another that makes most understandable by doing normalization or aggregation and integration. Data integration, like data we need to process will not be available in the single sources. Sometimes it can be from the different sources. Of course, if we do not integrate them, it will create a problem with pre-processing. So integration is one of the important phase in pre-processing. And reduction, like when we work on data it may be complex, so as we are humans it is difficult to understand, so to make them more understandable, the system then reduce them so that to required format then we can achieve good results. This is about the procedure, and this is the attributes to be collected to predict whether the person is having the heart diseases or not, and this is one of the sample data sets that have been chosen. And proposed system, and the figure shows the functioning of the system that is described step by step. So the data set in the first we can see the data set contains the details of the patients, don't know. Then the attribute selections takes the attributes which are useful for the prediction of the heart disease. After identifying the data from the available resources, they are further selected for processing, like which includes data cleaning, as I've already told, removal of noise and missing data. So different classification algorithms are performed on the reprocessed data to find the chance of getting RDCs. Like you can see logistic regression, random forest, naive Bayes, gradient boosting, and support vector machine. This is prediction. It helps to find the accuracy of the algorithm and compares the accuracy among all the algorithms. And the one which is having highest accuracy, that is chosen to predict whether the person is having heart disease or not, or likely to get heart disease or not. Methodology. So what are the methodology, like as I've told, five algorithms which we are using: logistic regression, naive Bayes, random forest, support vector machine, and gradient boosting. So logistic regression, as we all know, it is well known for binary classification, and it is one of the most efficient machine learning algorithms, like due to its simplicity, and it has its application on a wide range of problems, and it also provides the suitable solution. Logistic regression predicts whether the something it's true or false. Like it's an S-shaped logistic function. It is usually used for classification. Logistic regression can work with the continuous data. So it does assume like a linear relationship between the input variables and the output is supervised. Next is naive Bayes. So naive-Bayes classifier is also the best classification algorithm in machine learning. So it uses the Bayesian algorithm, and it is also strongly scalable, and it requires variables linear in the form of predictor variables in the problem statement, and it also identifies the speciality of the patients related to the disease. Next is random forest. So random forest, it is also machine learning algorithms, as we all know, and it's used for classification and regression. So is the speciality of this random forest is it creates the decision trees for each attribute. It corrects the overfitting to the training set, and it also avoids the missing values outliers by following the steps of data analysis, data preprocessing. Random forests are built from decision trees. Decision trees are easy to interpret. Random forest combines the speciality of resulting in vast improvement in accuracy. Supervised random forest, it creates the decision tree on data samples and then gets the prediction from each of them, and finally selects the best solution by means of voting. So this is about random forest. So next is support vector machine. It is an algorithm which is used in machine learning, and it's used for classification and regression, and it is the regularly used as the classification techniques due to its efficiency when compared with the other algorithms. This technique plots a hyperplane for every attributes as a coordinate that is present in the data sets, so that we can get proper analysis. And the lastly, gradient boosting. So gradient boosting, it's used for regression and classification technique. So which has a group of weak prediction models that are like the that of decision trees. This technique provides a variable importance of the attribute that is related to predict the heart disease in this dataset. Many models work together to find out gradient boosting is a special type, and which is works on reducing errors sequentially. When combined with the previous models, minimizes the overall prediction error. So the key idea is to set the outcomes for this next model to minimize the error, and it can also overfit the training data set. So the main advantage is that this project proposes a prediction model to predict whether the people have heart disease or not, and to provide an awareness or diagnosis on that. It can be done by comparing the accuracies of applying rules to the individual results of algorithms taken to present an accurate model of predicting cardiovascular disease, like which is a major advantage. The major drawback is that the accuracy of each algorithm must be calculated. That is a time consuming. And result analysis and discussion. The output and the accuracies generated are reviewed and results are displayed. Like in this, the algorithm which has the highest gives the more accurate results. The accuracies arises from the attributes collected from the datasets. If the dataset is not there, means it's very much difficult to predict the accuracies. So datasets are the very much important to find out the accuracies. These accuracies can be increased with the help of better and datasets sorry, these accuracies can also be increased with the help of better and data sets based on the accuracy produced by the algorithms. The best algorithms which gives accuracy is chosen for prediction. The user interface is designed in such a way that it is it can in such a way to use effectively by the user. And also, like as I've previously told, the 14 attributes that get to the patient produces the appropriate results that is predicted with the help of algorithms. Like as we know, the highest accuracy gives the most accurate results, and accuracy arises from the attributes that are collected from the data sets. So based on the accuracy produced by the algorithms, the best algorithm which gives accuracy is choosing for finding the predictions. So in this slide, we can see the accuracies that have been compared, like 5 algorithms which have used logistic regression, random forest, naive-bayes, gradient boosting, and SVM. And this is the performance of the comparison of the performance of the algorithm. So this is results like we can see here the patient's age, gender, like chest type, pain, resting blood pressure, and cholesterol. And we can see here the probability, like if the probability is less than or equal to 3, like then there is no heart disease. If the probability is greater than zero point 0.3 and less than zero point 0.7, then we can say that there is mild heart disease for that patient. And the probability sorry, if the probability is greater than zero point 0.7, then there is a danger and the person must consult the doctor immediately. Like this way, it's very much useful whether we can know whether we are having mild heart disease or no heart disease or severe heart disease. And conclusion. So, this paper contributes the correlative application and analysis of distinct machine learning algorithms in the software. So, in this paper, we have studied the various machine learning algorithms that is used for the classification of heart disease database, that we have seen different techniques obtained by them. So, to sum up, pre-processing is a crucial step in machine learning and it helps us to achieve better results. So further work includes the different ensemble methods of these algorithms, which can advance to better performance with more parameters of these algorithms. And these are the references which I've taken. Thank you.